Hi everyone, it's great to be here with you for the next 30 minutes live. My name is Dania Meira. I am the founding member of the AI Guild and I am the director of Data Lift. Welcome to everyone that is joining us live. Please be active and send us your questions via chat. We will answer them on the fly. Today with me is Andrés. Andrés is a computer vision engineer with more than 3 years of experience in the Berlin startup scene. He's currently working at Footprint Technologies, where he has developed an image-based solution to precisely measure feet, from prototype to a market-ready product. Thank you, Anders, for joining me for this chat today.
Thank you, Annie. Happy to be here with you.
Cool. So to get started, maybe you can share with us how did you get to where you are today? How did the interest came about computer vision?
Well, I have a background in telecommunications that I did my bachelor in Madrid, in Spain. And one of the subjects that I have in my final course, I think, was related with classification. So the teacher came to us and he proposed a project, and we had to compete among ourselves to get the best accuracy and the best metrics over a classification problem. This was 2014, I think. So deep learning was not a thing, or it wasn't as active as it is today, and I had to build watermelon classifier. So just trying to understand what are the properties that define a watermelon. So I had to find different levels of green and red that you could find in an image, and the round shape that you could find, because watermelons are rounded, are like spheres. And it caught my attention. I was really stubborn with that problem. I spent lots of hours on that problem. I actually missed some exams because of that problem. And
Well,
I liked it very much. Missed other exams from other subjects, and I liked it very much. And I thought, like, hey, this is what I'm really interested on. So I then found a computer vision and image processing, and I went there. This was this Erasmus Mundus computer vision program, which was held in 3 different universities across Europe. So I got to meet people from different parts of Europe, and finally I ended here in Berlin, where I started working for a agro-tech startup, building a classifier. Once again, after 3 years after that, about a plant disease classifier based on image processing, basically. This is that you would actually take a picture. There are lots of apps right now, but it was pretty focused on some crops in India. So farmers there will be targeted. The data set was basically gathered there, and it was targeted for specific crops and specific diseases. So it would be easier just to develop this type of tool. And after working that startup, I had the opportunity to join Footprint, and I jumped right in because I really liked the idea, and that's what I've been doing for more than two years now. Sorry.
thank you. Yes,
Yeah.
it's quite interesting how it's something that you have been in contact from early, and you managed to keep like iterating on this idea, and also together with the evolution of the technology itself, how much you have also learned. So this is actually the topic that you are going to talk about during the Data Lift Summit. So this is also the reason why we are going live now, to tell people a little bit more about what is your session about. And here I put the title on the screen. So it's finding the fitting shoe size with end-to-end image processing. I would like to unpack the title together with you so you can help me and the audience to understand what do you mean, for example, with the fitting shoe size. Can you tell us a bit more about this?
Sure. Finding the fitting shoe size means that I am in charge basically of measuring feet, and finding shoe size, in the one hand you need the measurement of the feet, and in the other hand you need the shoes. You know, European in the European, from one side to the next one, there's difference. So from 39 in length, you for example, you 4-6 meters, which is that this needs to choose 4 grams. High for this point, but basically last shoe model made it. We have
I think Andres is not with a very stable internet connection. Let me see if I can get him back. Hi, I think we are back.
sorry, I don't know how I lost the connection, but I was just saying that the last shoes are made around this model, which can be made of, for example, done to the and this model it could get eroded after thousands of shoes eroded from the front and from the back, and actually 2 millimeters, which is a third of the shoe size. What I'm trying to say here with all of this in-depth explanation of how the shoe industry works is that it's finding the fitting shoe size. It's a really accurate process into consideration really shoe measurements. We also inner shoe dimensions. First part. The
Okay,
second
so,
part.
yes, so the shoe size fitting with the feet, this is something that you do, like you do the both measurements and then you are able to recommend the match or the best match between that. Do I get it right?
Yeah. Yeah.
Yes. This sounds like
I get
something that I could also use. Okay, then the next part is this end-to-end image processing. Can you tell us a bit more about that?
Yeah, the end like it needs to have two problems, right? It needs to the measuring part and finding the fitting shoes. What I meant to end means that the problem was proposed and we didn't have any data. This startup dream or idea that the founders had, and we had to start from. Sorry, hi Johannes. Sorry about my. Don't know what, but I see you very well. Can you hear me?
Yes.
Danny?
Yes. Yes. I hear you
So
well.
we had no. So we data capturing tool, data capturing process, which meant me, along with the startup, we would go to different places and we would actually measure feet, which is a very critical to do, mainly as a you would say like, hey, I'm doing this, and if I measured your feet. And this was kind of, there were fun moments there, but we needed to, but not lots of data, because this was, these were process, and we needed to scanner, which would have, and then do measurements. And all the data, we need to label the data, and we need to do models and deployments in the deployments to be able for every phone, as any other.
Yes, we got a question here. What and how much food and shoe data do you have or you need? I think you addressed that a little bit about the collection of this data, and if you have any idea on also the volume that you need.
So, to be honest, what I'm using as a model, it's not directly, I have images and then I get the measurement model. I couldn't build that. I couldn't reliably build that. We would need, as a regression problem, we would need thousands of data, which access to basically not humanly possible. So what I did basically was just find us working with segmentation models. This model tells me where's the food, the paper that I'm currently need, because I'm working with uncalibrated cameras, and need as much as I thought after gathering some hundreds of video sets, turning around and segmenting all of the feed. We came up with robust segmentation that are, of course, every day, but they are with, if it was 400 or 500, and the data segment the feed correct.
Nice.
I didn't expect this, since we are dealing with, and also the environment control, since you always your food, and then you have, you could have floors, right? You could have, in the end, it's pretty controlled, reduced. So that much data at the beginning, time improving since it's getting better.
Yeah, that's interesting, because there's a lot of talk about big data, or like the more data the better, but that's not always true, right? What I'm getting from your experience is that it's not about having more data, but having quality data, even if it's a small data set, but it's something that you can work with, because you can segment and you can add the labels and so on.
Exactly. It's more, it's having a quality data set, really having a control use case with, you can increase the, until then it was.
Yes, got it. Thank you. So maybe you can also tell us a little bit more regarding the image processing part, because you mentioned the videos and so on. So maybe you can tell me a little bit, how do you see this expertise to work in computer vision, to work with videos and image processing, or even the image segmentation you mentioned?
As I come from computer vision and image processing, being as a tool and more like image processing algorithms, I didn't teach myself on other regular machine learning, other type of data. Let's say I didn't teach myself. I didn't develop many tabular data models. I didn't develop or these type of models that you would use with big Excel sheets or tabular data or NLP. I didn't do much of that. And when it came to measure the feats, it was like, okay, it would be great. We could have simply a regression problem. You input a couple of images, but I found that, as I was telling, it was not doable. This won't solve the problem. This is not a valid solution in the short term. So in the end, needed to come down to develop an algorithm which was purely software. In the end, it's image processing, and treat the models or the data as segmentation models, just as a tool, as a part of my pipeline of different models to process the final measurement. This is very useful when I was doing some tutorials or just networking with other people in the community, that I saw that treat images as any other type of data, like, without really understanding the context or what's the image or what's understand an image, which is different of how of data. It's not only we're talking about some 2D or 3D data volumes, but we are understanding some context. We are understanding some spatial relationships. And it's not only about numbers; it's more about understanding what you're seeing there and just sense it. In the end, I'm using the model and the data as a tool. I just need to extract information from the images to keep on going with it.
Yes, I think what I am hearing from you is that it's a fundamental difference between this type of data, even though it's again being transformed into a matrix or vectors of numbers. It's fundamentally different than because it represents the image, which has, for example, this the visual context, or it even has the interaction between, let's say, the pixels around it or the numbers around it, which is very different if you look at, for example, tabular data or text data.
Yeah, and also the here from model, what I get is the representation of the 3D world. So you need to understand also what are the representations of into the 2D measure. It's also very how and then
I'm losing you.
issues.
Can you please
Hello?
repeat? I lost you at the end.
I was saying that it was interesting how just get information from the 3D world, some sense, and then understand, extract the information from the 3D world into, and then all that to feed to the 3D abstractions.
Yes, and maybe then connected to this, I'm sure you discovered a lot of things, or you got to learn a lot of things during the development of this project. And I'm wondering if you can share with us some insight from your area. Let's say, maybe you can share with us some challenge that you think the computer vision field is facing.
Yeah, what I've learned, thanks to the last thing that I was saying, what I learned is that you need, in order to measure and to try to with the team to find a working solution, which is not just computer vision in the end.
Mm-hmm.
Do this. There were. Are you losing me? Okay.
Yes.
Can you hear me?
Not yet. Now you're back.
I have connection. I saw you are very good software development, data scientists that develop a lack of talking with the real food experts. So, for example, people are operators of hours, other people, you can measure the food sitting down. This actually would pressure that you put on the food. So instead, your food of being like completely pressed against the floor, it would be a little bit lifted. So you would be losing even per part of the food, and that would add up into 4 millimeters, and that's more than half a size. So are developing measuring feet measuring solutions, but they don't have this feeling of talking about the feet experts, because they are really good at understanding this, and the industry knows this, and this was one of the things that really give us a push. Why are you doing this like that? So
I think I lost the beginning.
You need to understand. Then I will quickly repeat, but basically you need to know that we are dealing with shoes, we are dealing with feet. So you need to understand how the shoe industry works. You need to understand how a pregnant woman is your shoe size as an adult. I mean, if you don't overweight, if you just gain 30 kilos, you don't 80 meters. And since you wake up at night, be up to 2.5 to 3 length. So all of this will be taken into consideration in the whole end-to-end pipeline. Not only that we need to gather, that you need to collect, not only the models that you need to train, you need to build, but you need to apply logic into these processes. And
yes,
yeah, that's what I've learned, that you need to know about this.
Thank you. Now I think I got it. So the idea is that in your case, because you're doing the match between the shoe size and the food size, you really need to understand both worlds so you can have a solution that will do the perfect match. Otherwise, you can have kind of solve one side or the other, but to be able to provide value to both in combination, you really need to dive deep into those, let's say, domains. And of course, talk with the experts, talk with the users, and understand what are the contexts that they are in and the challenges that they face.
Exactly.
And I think I can relate to that from my experience, or also working in data science, because even though we very much fall in love in like the models and even programming, those are the tools that we use, and the end goal is really to be able to provide some value. So fix a problem, find a solution, and that is not on the data per se, or it's not on the models per se, but it's on how it's going to be used or who is going to use it. That makes a lot of sense. Thank you for sharing. Before we leave for today, I would like to ask you one last question, if that's fine. Would you share with us your thoughts on the importance of deployment? Because data lift is about deploying solutions, making the machine learning or deep learning solutions to production. And yeah, I'm wondering if you would share with us some thoughts on the importance of deploying, and more specifically, deploying computer vision solutions.
It's the whole key. It's what really brings value. The deployment is important as any other thing, and that's I thought, okay, that this is, and I can develop some scripts to deploy this. Then you need to know exactly, and the deployment, it's a very crucial point of how to deploy the computer vision solution. Scalability also, because you need to be aware that where how peaks and when are you buying shoes, because you need to apply solutions are really high functional, so you need a lot of resources to process images and videos. At 3, there's a point about 10 GPU.
I think I lost you again.
Be done deploying particularly computer. Hello?
Yes. You were saying
Sorry about it.
something and then got lost. Would you please repeat the last part?
Yeah, basically the computer vision solutions that need to be deployed are expensive, so they should be optimized about deployments, and then you need to spend lots of time find the trade-off between accuracy and speed and the resources you need to use for this. And you cannot have a user waiting 15 seconds for processing their, because you will lose them. They don't wait that much. So you need to find an optimal solution that you have all of the things balanced. And that's crucial. That's everything about deployment. Yeah.
Yes. Thank you. Thank you for that insight, because yes, once we are in the developing stage or building models, maybe this is not something that matters so much, like what you mentioned, that it's computationally expensive, that you need to see if you really need to do that or not, because it can get expensive, or it can get, the user can get annoyed because of waiting. So all of that could really make the entire project fail, doesn't matter how accurate the model is at the end. Yeah. Thank you very much. Thank you, Andres, for joining me for this talk today. And also thank you for anyone that is watching us live. And I would like to ask you to please go check out our Data Lift Summit. Please come to Berlin, join us, join Andres' session about finding the fitting shoe size with end-to-end image processing. You'll be able to meet him in person, hear directly from him, and also ask any questions you have about the work he's developed. Thank you.
Yeah. Thank you very much for being here, both of us. And in the summit, it will be in person, so I won't have connection issues, I hope. That will be. See you there.
Cool. Thank you. Bye-bye.